Alright guys, welcome back. Last week here of e-learning. So guys, today we're talking about substitution. Last week we talked about elimination method for solving systems of equations. Guys, today it's going to be substitution. So guys, what substitution really is kind of based on is the idea, and this is something we all understand here. If you look, guys, 4/4 is equal to $1. Right, these things are interchangeable. If I gave you a $1 bill or I gave you 4/4, I gave you the same thing. They're interchangeable. Okay, so this idea of things being equal means you can substitute them. Like I said, we could trade $1 and 4/4, a dollar bill and 4/4, and nobody's losing out. You know, we each have the same amount. So they're interchangeable, they're substitutable. Okay, so when we say things are equal, that's what we're saying. Okay, so that basis, if we look here at problem number 1, we say y is equal to negative 5x plus 15. We can substitute that negative 5x plus 15. We're going to take it and we're going to substitute it for y in the other equation. So this bottom equation, negative 6x minus 4, I'm taking the y out and I'm substituting what y is equal to. And anytime we substitute, guys, I'm using parentheses there. So instead of y, I took it out and put in parentheses what y was equal to, negative 5x plus 15. And then I write the rest of the equation equals negative 4. Okay, the reason for this substitution is this new equation that I just wrote has only one variable. It has an x variable. So this is an equation you can solve for x. Of course, guys, we're going to see the distributive property here. That's going to be negative 4 times negative 5x. So that's positive 20x. Negative 4 times positive 15. That's negative 60. And we got to bring down that negative 6x. Combining like terms here, guys, that's going to be 14x. Negative 6 plus 20, that's 14x. We're going to add 60. Yikes, guys. Apologize here. I don't know why, but I wrote negative 40. It's negative 4. Apologize there, guys. So adding 60 to both sides. Now we got 14x equals 56. Okay. Dividing by 14. At this point, guys, probably calculator, negative or 56 divided by 14, I think is what, 4? And so we got x equals 4. Okay. From there, guys, we're going to take this x equals 4, and we're going to substitute it for x up here. Because we're solving a system, guys. We have to have an x and a y. So now we got y equals negative 5, substituting 4 for x. And we just solve. We simplify here. So negative 20 plus 15 is y equals negative 5. Our solution to the system, our xy ordered pair, is 4, comma, negative 5. All right. So, guys, there one equation was already solved for one variable. So, pretty easy to jump into the substitution. Here's a slightly different case where two equations, they're both solved for y. Okay. When this is the case, it's the same idea. Take one of the expressions and substitute it into the other equation. So if we're taking out that y and plugging into x minus 20, then that's what the left side of the equation becomes. Okay. The right side didn't change. So at this point, guys, we're, adding 5x to both sides. So that's 2 plus 5, that's 7x minus 20 equals 22. Add 20 to both sides. 7x equals 22 plus 20, that's 42. Divide by 7, and we get x equals 6. Again, from here, we're taking x, and we're going to substitute it either equation, guys. I'm going to go back to that bottom one there. So it's going to be y equals negative 5 times 6 plus 22. So that's negative 30 plus 22, which is negative 8. So our xy ordered pair, guys, we got 6 comma negative 8. That's our solution to the system. That's the point that satisfies both equations. All right. One more slightly different example here, guys. Neither equation is solved for a variable, okay? But that's okay. All right, if we look at this bottom equation, I'm going to rewrite it here. Guys, we could get x by itself by subtracting the 2y. Now, of course, if I do that to one side of the equation, I've got to do it to the other. But then we get x equals, well, what? Negative 2y minus 6. Okay? And now we can substitute. We can take that negative 2y minus 6, and we can substitute that. Well, we're substituting it for x. Okay, so this one's a little different. The other ones we've had y where we substituted. Well, you can also do the same for x, guys. So looking at that top equation now, if I take the x out and I substitute in negative 2y minus 6, then I got minus 7y equals 14. So this is something I can solve for y. So I get positive, that's negative 7 times negative 2, so that's positive 14y plus 42 minus 7y equals 14. Subtracting 42, we're going to get 14y minus 7y equals, what is it, negative 28. 14 minus 7, so that's 7y equals negative 28. I've got to scroll a little bit here, getting kind of squished. Divide by 7, and we've got y equals negative 4. Guys, from here, I would take this and I'd go right back to the equation where I'd already solved for x. So I'd be looking at x equals negative 2, substitute in y, and so we've got x equals 8 minus 6, so x is 2. Our ordered pair is 2, negative 4. Okay, that's our solution. Alright guys, last one. Maybe you guys pause and give a shot on your own, okay? Again, no equation is solved. This bottom equation, though, you could probably get the y by itself pretty easily. Subtract the 3x. So just pause, give that one a shot. Guys, I've got two homework problems on here for you, so if you guys have got questions, shoot me a message, all right? Everyone have a good afternoon.